Voyager 1 was never expected to uncover another mystery. After nearly 5 decades traveling away from Earth, scientists believed its remaining task was simply to keep transmitting for as long as its fading power allowed. Each year its signal grew weaker, its instruments aged, and its tiny nuclear power source produced a little less electricity. Everything suggested the mission was slowly approaching its final chapter. Then something unexpected appeared. During one sequence of transmissions, researchers noticed an unusual pattern hidden within Voyager's data. At first it looked like ordinary electronic noise, the kind of small irregularity engineers often expect from a spacecraft built in the 1970s. But as they examined the information more closely, they realized the disturbance did not behave exactly like a simple hardware problem. The strange pattern seemed different. It raised an uncomfortable possibility that the source of the anomaly might not be inside Voyager at all. It could have originated in the enormous region of space surrounding the spacecraft. That single possibility transformed an ordinary engineering question into something much larger. Voyager 1 is unlike any spacecraft humanity has ever built. Launched in 1977, long before smartphones, social media, or even the modern internet existed, it was designed during an era when space exploration represented humanity's greatest technological adventure. Its original objective was straightforward: fly past Jupiter and Saturn, study their systems, and complete a mission expected to last only a few years. Instead, Voyager rewrote history. It revealed the violent storms of Jupiter in extraordinary detail, discovered active volcanoes on Io, exposed Europa's cracked icy surface, and transformed our understanding of Saturn and its magnificent rains. It later captured one of the most iconic images ever taken, the pale blue dot, showing Earth as a tiny point of light suspended in a sunbeam, reminding humanity how small our world truly is. But Voyager's greatest journey began after those famous discoveries. Instead of shutting down, the spacecraft continued moving farther into darkness than any human-made object had ever traveled. It crossed the outer planets, left the familiar neighborhood of the solar system behind, and eventually entered interstellar space, the vast region between the stars where the sun no longer dominates the surrounding environment. Out there, Earth is no longer visible as a bright world. Even sunlight becomes little more than another distant star. Every radio transmission Voyager sends must travel across billions of kilometers before reaching the giant antennas of NASA's Deep Space Network. By the time those signals arrive, they are unbelievably weak, almost buried beneath the natural radio noise of the universe. Scientists don't simply receive Voyager's messages. They carefully search for them, separating the spacecraft's tiny voice from countless other signals filling space. Every bit of information must be cleaned, corrected, decoded, and verified before anyone can understand what Voyager is trying to say. That is why even the smallest irregularity attracts immediate attention. A tiny fluctuation might indicate a failing computer. It could reveal damage caused by cosmic radiation. It might be nothing more than a worn-out electronic component nearing the end of its life. Or it could reveal something entirely different. Beyond Pluto lies an invisible boundary called the heliosphere, an enormous bubble created by the solar wind flowing outward from the Sun. Inside this protective region, magnetic fields and charged particles are largely controlled by our own star. Outside it, the environment belongs to the Milky Way. When Voyager crossed that invisible frontier, it entered a place no spacecraft had ever explored directly. Interstellar space sounds empty, but it isn't. It contains incredibly thin plasma, powerful magnetic fields, energetic cosmic rays, and ancient material drifting between stars. Shock waves from long-dead supernovae continue moving across the galaxy for millions of years. Invisible forces constantly reshape this environment in ways scientists are only beginning to understand. If something unusual existed out there, Voyager would be one of the very few instruments capable of sensing its effects. That possibility became even more intriguing when engineers noticed the unexpected variations within the spacecraft's transmissions. Initially, nobody was alarmed. Old spacecraft experience problems. Electronic circuits weaken. Memory systems fail. Software written decades ago can behave unpredictably after years of exposure to extreme radiation and freezing temperatures. Every engineer involved with Voyager understood these risks. The simplest explanation was that the spacecraft itself was showing its age. Yet the anomaly refused to fit perfectly into that explanation. Instead of looking completely random, the pattern seemed to change in a way that appeared connected to the environment surrounding Voyager. If that interpretation proved correct, then the disturbance wasn't simply a malfunction. It could represent the spacecraft moving through an unusual region of interstellar space. That distinction changes everything. A failing computer tells engineers how an old spacecraft is dying.